Hi, my name is Quyen from HelpAge International, and welcome to my presentation on climate change, older people, and biochar.
Two most pressing challenges for humanity in the 21st century. First challenge, rapid aging.
In 2020, older people make up 13.5% of the world population. This will increase to 21.4% by 2050 and to 28.2% by 2100. Many people, especially policymakers, are very concerned about this rapid rise in the number and percentage of older people. However, current and future older people are and will be more educated, healthier, wealthier, and more active than past generations. If they are invested, they can be major players to help reverse climate change, global warming, and promote sustainable, equitable, and inclusive development.
Second challenge, climate change.
Unfortunately, our carbon footprint is projected to increase, mostly due to the following reason. 1. Population growth. We will reach 8 billion by 2023 and to 9 billion by 2037. Second, our GDP is expected to continue to grow, which will lead to higher consumption. And third, and lastly, urbanization. 56% of the world population is currently living in urban areas and will increase to 69% by 2050. Our total CO2 emission or our annual carbon footprint is 40 billion tons per year. Therefore, it is very important for us to find a way to offset this amount. So what action can we take to reduce climate change and global warming? To help us decide what action to take and what would be their impact, we have this chart. Not all action has the same or equal impact. This is a chart showing the annual CO2 emission saving by activity. For example, if you change to eat a plant-based diet, you would save this much per year. If you change to eat only or mostly local food, you will save this much. Or have one fewer child, you can save this much. However, if you decide to be a full-time biochar maker, you can reasonably save 1,000 tons of CO2 annually. Yes, this is a big wow. Looking at the bigger scale, to combat our climate change and global warming problem, we need to select the right solution for the right scale of the problem. If our climate change global warming problem is this size, our plan A, which for the last 30 years has been to reuse, reduce, and recycle, would be the perfect intervention. Plan A would not stop global warming, but will slow it down. However, if our climate change global warming problem is bigger, Plan A would not be enough. We would need to add Plan B, which focus on being carbon neutral, such as moving away from using fossil fuel to renewable energy like solar, hydro, wind, and bio. However, if our climate change global warming problem is very large, it is gigantic like the size of Godzilla, then Plan A and Plan B is not enough. We would need to add Plan C, which is carbon negative. Carbon negative can enable us to reverse global warming by offsetting current and past emissions. To help us have a clear picture, this is a chart showing the projected global CO2 emission and rise in global temperatures by various intervention plans. If we continue with only Plan A, global temperature is projected to rise to above 2.5 by 2100. If we implement both Plan A and Plan B, global temperature will increase by 1.5 to 2.5 by 2100. However, if we implement Plan A, Plan B, and Plan C, we can stop and reverse global rise in temperature. Just to note, according to climate change specialists, our remaining carbon budget to stay below 1.5 degrees Celsius would likely be used up before 2030 and below 2 degrees Celsius before 2040. So the time we have is very, very limited. Let's do a quick review of the carbon cycle. CO2 is in the atmosphere. Vegetation, when it grows, captures the CO2, but when it decays, used, eaten, or burnt, it will release the CO2 back into the atmosphere, as well as other very harmful air pollutants, which has many serious negative environmental, health, social, and economic impacts. So, the weak point of the carbon cycle is its short carbon storage capacity. However, if we add biochar to the carbon cycle, it can compensate for this weakness. Converting vegetation or biomass into biochar will release about 20% of the CO2 into the atmosphere, but will capture the remaining 80% into the biochar. Biochar is very well known for its special capacity to store carbon safely for a very long time. Here is the flowchart of our vegetation and biochar scheme. First, farmer grows the crop. They harvest the crop and gather the food. They then take the biomass waste and convert it to biochar in 1 to 2 hours. The biochar is then used to make soil enhancer and other health and environmentally friendly products. Using biochar enhancer will increase crop production. With each cycle, you would be able to produce more food, use less water and fertilizer, and produce more and more biochar. There will be less and less CO2 and air pollution in the atmosphere. There are many ways to make biochar. However, the one that we are promoting is by far the fastest and the easiest method to learn, to set up, and do. It requires the lowest investment, does not require infrastructure like road, electricity, building, or running water. It is very mobile and easy to transport to anywhere in the village or community. You can move it to the biomass. It is designed for poor and small rural and semi-urban community. It also can bring multiple benefits such as reversing climate change and global warming, dramatically reduce air pollution. The most common question we receive relating to our biochar scheme is there enough biomass? Will it cause deforestation? Our response is we only need to convert 2% of the biomass waste that is produced annually by the farm into biochar to get 40 billion tons of CO2 per year. This is a typical $1,000 village-sized biochar making scheme. It can make 1 to 2 tons of biochar per day. This is a simple diagram of our biochar making scheme. Daily, 2.5 tons of biomass is converted into 1 ton of biochar. We contain 0.8 tons of carbon, or equivalent to 2.8 tons of CO2 per day, or 1,050 tons of CO2 per year. What would it take to scale it up globally? Let's do the math. If we scale it up to 40 million village or site, we'd be able to capture or store 42 billion tons of CO2 per year, which is larger than our current carbon footprint. There are 570 million farms in the world. 97% of the farm are small-scale farmers, having less than 10 hectares of land. Most of the farmers are aging 50 years plus, and many are underemployed. These farms annually capture, when they are farming, billions of tons of CO2. However, the CO2 and harmful smoke are quickly released back into the atmosphere when they use it and burn it. If 8% of the farm make biochar, they can capture and store more than 40 billion tons of CO2 per year. In addition, using the biochar in farming will also improve soil health and increase vegetation growth, which will capture and store another 10 billion tons of CO2. So this can offset past CO2 emissions. Capturing and storing 40 billion tons of CO2 will cost about $80 billion, which costs 200 times less than the second best option. Government can support by providing subsidies, grant, carbon credit, and loan. Carbon credit scheme, for example, like $20 per ton of CO2, can provide employment to at least 100 to 200 million rural farmers, can be attractive incentive for younger generation to become or remain future farmers. Evidence of long-term benefit of biochar. Terra petra, or black soil, is a fertile man-made soil found in the Amazon basin. It was made by Amazon Indians hundreds and thousands of years ago to improve the infertile Amazon soil. Terra petra soil can remain fertile for hundreds and thousands of years. Here is another example of using biochar to reclaim degraded land. This is a photo of a 100-year-old mine in Colorado, which have lost all of its topsoil and is contaminated with heavy metal. After 1 year of applying biochar, the result can clearly be seen. It normally takes Mother Nature around 1,000 years to make 1 inch of topsoil. Biochar can do it in a few years. Using biochar will dramatically increase the growth of biomass. Conclusion and recommendation. There is a saying, solution is often found within the problem. Small-scale farmers are often blamed for being the main cause of climate change and air pollution. In fact, they can be the solution to the problem. Small-scale farmers are capturing billions of tons of carbon by growing crop annually. However, they quickly release it when they burn it or use it. Why? Because they do not have any other options. With biochar, instead of burning it, they can convert it into biochar to increase the food and income security while also reversing global warming and reduce air pollution. Offsetting 40 billion tons of CO2 is very doable with biochar. The number and percentage of older people and their older people association is rapidly growing. In the Asia and Pacific region alone, there are more than 700,000 OPAs with hundreds of millions of members. If they are invested, they can scale up biochar awareness, production, and usage to national, regional, and global scale. $1,000 per village scale biochar site is very affordable. Increased biochar production and usage will reverse climate change and global warming, reduce air pollution, improve food and income security, and help country to reach many of its SDG targets. Now I would like to invite you to see a video highlighting the roles of older people in 4 countries promoting the awareness, production, and usage of biochar.
ของโลกปัจจุบันที่ร้อนขึ้นเกิดจากการปล่อยคาร์บอนของมนุษย์เพราะว่าถ่านไบโอชาร์จะเป็นตัวที่จะช่วยดูดซับคาร์บอนในอากาศและก็ดูดซับสารพิษรอบตัวเรา
Than sinh học rất dễ và nhanh, không tốn nhiều kinh phí. Than sinh học có lợi cho môi trường, vật nuôi và cải thiện đất bằng màu. Tôi mong rằng tổ chức 2, người cao tuổi các cấp, chính quyền các cấp nhân rộng mô hình này trên toàn quốc và chúng tôi được hưởng lợi.